Okay, here's another reverse chain rule integral. In other words, we have we have the e to some function of x times function prime, and when we take the antiderivative, we'll just get e to the function of x, e to the function of x, plus any constant you like. The reason, of course, if I take the derivative of this, I'll get this times function prime. Now, here's an example, and the first thing I look in here is this 1/2 is kind of a distraction, so I'm going to pull that out. And I'm going to put 1/2 here, the antiderivative of e to the negative 10x dx. I'm going to put dx way over here. The reason is I'm going to need f prime. It says I need f prime here. And luckily, this is just, f prime is just a constant. It's negative 10, okay, times negative 1/10. You might ask, well, wait a minute, where did I get that? Well, I need negative 10 there, but I can't just put it in there. I have to multiply it by negative 1/10, because that's just 1. Now, I'm going to take out the negative 1/10, and it's going to be multiplied. It's negative 1/10 times 1/2 times e to the negative 10x times negative 10 dx. Okay? Now I've got e to the f of x times f prime, and this stays, I mean, well, this is just times this integral, right? Which is what, negative 1/20th, I guess that's all it is. And so my final answer, of course, is this is just going to go to e to the negative 10x plus a constant, but then, of course, this stays, and that's, we'll put negative 1/20. I hope you can read that. Negative 1/20. It's hard to write on this board. It's funny, isn't it? Just right there. There's negative 1/20. So our final answer is negative 1/20 e to the negative 10x plus constant. And this is typical. And this had an extraneous constant here. I just take it out. It's a distraction. If it wasn't there, I'd do the same thing. But it's there, so I have to bring it out, and I bring out negative 10. It's negative 1/20th. Because I bring out the negative 1/10, and I end up with negative 1/20th e to the negative 10x plus c.